Okay, so this is again the lecture series of a PH 3501 Unit 1 Solid State Physics by Dr. R Gadhvi. Now, in this present slide, we will be calculating about Madelung constant, and as the title has given, calculation of a Madelung constant of ionic crystals. Oftenly, it is asked as a important question in your regular exam, and it would be weighted by around 7 mark. Madelung is a name of scientist, and he has proposed the very first model to speculate or to calculate about the uh, energy proportional constant, which is lying for the ionic crystal. Now, it is as it is mentioned here, it is a property of a crystal structure, and it is strongly depend on a lattice parameter, anion and cation distance, or a molecular volume of a crystal. And in general, we do have a ionic crystal, which is obviously having a three-dimensional setup. But to directly propose with the three-dimensional setup, it's better to start with the easier part of modeling, and therefore the author of this book has split up this topic in a two part, and the first part is a hypothetical one-dimensional model. As the adjective mentioned here, the hypothetical is basically a conceptual. That means one-dimensional crystals do not exist. So, to understand the three-dimensional setup, let's begin with the one-dimensional. One-dimensional, that means either the periodic arrangement of the lattice or a unit cell or a building block in a direction of one of the axes. It could be x-axis, it could be y-axis, or it could be z-axis. As the figure has given, it is along the x-axis, and the zeroth ion is position, that is the sodium ion. So, as the axis or a one dimensional crystal, it's many other authors has mentioned with the word monodimensional crystal, or some author are also given the name unidimensional crystals. All are basically synonyms: one dimensional, unidimensional, or the monodimensional crystals, which do not exist in physical world, but just for the hypothetical or the conceptual part, it is name given so. So let's assume that and set up our periodic arrangement of the sodium chloride crystal in such that, so the nth sodium ion is situated on the zeroth or the origin of the axis. So if I will focus it on the either side of that zeroth position sodium ion, then at a lattice constant or at a r0, or it's a equilibrium distance where a bond could be formed between an sodium and an chlorine ion, and that is a r0 equilibrium distance, and therefore as indicated by two blue arrow, the next adjoining ions are chlorine. As they are in a opposite ionic state, so a sodium and chlorine do have the attractive in nature, and therefore the electrostatic energy, that would be the attractive energy. So if I will calculate it, naturally it would be preceded by the negative sign. If I further increases or move along the axis, positive axis as well negative axis on a one dimensional crystal, as it is shown with the light green arrow, and the immediate at a 2r0 position. Remember that r0 position is the position where the equilibrium distance is set up, and therefore a bond could be formed. Now at a double distance of that equilibrium distance, that is a twice of r0, I am finding again a sodium ion. Therefore, the zeroth position sodium ion and the another sodium ion situated at positive twice of R0 and negative twice of R0, as they are like charges, they do have the repulsive behavior, and therefore a repulsive electrostatic energy could be calculated. And similarly so on the axis or the hypothetical one dimensional crystal, as you increases your stable distance or equilibrium distance, your uh, like charges or dislike charges are periodically observed, and similarly you can calculate their energy in continuation.